entre las tres facultades de ingeniería de la Universidad de Talca, Universidad del Biobío y UFRO, como mencionaba Victoria. Es un proyecto Corfo que ya está en funcionamiento desde el año 2014, dentro del programa Una nueva ingeniería para el 2030. Y uno de los énfasis de los cambios que necesita nuestro país en el proceso de formación de ingenieros es una visión de la globalización. Y dentro de eso, entonces, uno de los 6 ejes estratégicos son las alianzas internacionales. En cada universidad se formó un equipo, un nodo de trabajo en el ámbito de las relaciones, de las alianzas internacionales, y en este caso particular, la relación con la Universidad de Nottingham ya existe hace varios años a través de la Universidad de Talca, gestionada principalmente por el doctor Marco Rivera, así que agradecemos las gestiones. Y por el otro lado, en Nottingham está el profesor Pat Wheeler, que también ya lleva una vinculación con la Universidad de Talca desde hace varios años, y eso en el marco entonces de la macrofacultad es una oferta, es una oportunidad para las comunidades universitarias de nuestras 3 facultades de ingeniería. En ese sentido, la idea es ver justamente el detalle hoy día de las oportunidades que a pesar de tiempos de pandemia, ¿no es cierto?, sí, a través de los medios tecnológicos existe la posibilidad de generar una especie de movilidad estudiantil virtual a través de la participación en primera instancia de la oferta de los distintos cursos en pre y posgrado, pero también, ¿por qué no?, en algún tipo de proyecto de colaboración y quizás más adelante, ¿no es cierto?, viajes presenciales, físicos realmente. Así que en ese sentido, esto es una tremenda oportunidad que queremos poner a disposición de nuestra comunidad universitaria, y la invitación es a mantenerse informados, a mantenerse conectados y aprovechar estas oportunidades. So thank you very much, Pat, for your very important collaboration during these years, and we hope we will have a good meeting now and a good day for you too. Thank you.
Muchas gracias, don Cristian. Agradecemos a nuestro director por sus palabras. Y bueno, ahora dejamos con usted al profesor Pat Wheeler, quien recibió su título en 1990 de la Universidad de Bristol, Reino Unido. Recibió su doctorado en Ingeniería Eléctrica por su trabajo en Matrix Converters de la Universidad de Bristol, Reino Unido, en 1994. En 1993 se trasladó a la Universidad de Nottingham y trabajó como asistente de investigación en el Departamento de Ingeniería Eléctrica y Electrónica. En 1996 se convirtió en profesor del Grupo de Control, Máquinas y Electrónica de Potencia de la Universidad de Nottingham, Reino Unido. Desde enero de 2008 es catedrático en el mismo grupo de investigación. Fue jefe del Departamento de Ingeniería Eléctrica y Electrónica de la Universidad de Nottingham del 2015 al 2018. Actualmente es jefe del Grupo de Investigación de Electrónica de Potencia, Máquinas y Control, director global del Instituto de Tecnología Aeroespacial de la Universidad de Nottingham, y es el profesor de cátedra LIDAXUM en Ingeniería Eléctrica y Aeroespacial. Es miembro de IEEE PELS ADCOM y fue un IEEE PELS Distinguished Lecturer del 2013 al 2017. Ha publicado más de 500 publicaciones académicas en importantes conferencias y revistas internacionales. Bueno, les recordamos a todos los participantes que pueden ir dejando sus preguntas en el chat o bien en la sección de preguntas y respuestas. So, Pat, are you there? You can start, please.
Okay, thank you very much. Thank you very much for the introduction. And my apologies that my Spanish is very poor, so I will have to speak in English. Can I ask the host if I can share my video so that you can see me as well?
Mauricio, ¿puede activar y permitir que Pat pueda compartir su cámara?
It's not essential, but...
La tiene que activar él.
Ok, Dice que no puede hacerlo porque... okay, Pat, give me 1 second. Let me try if I can... No. Mauricio, tú eres el anfitrión. Y necesito que deje a Pat Wheeler como coanfitrión, por favor.
¿Está? Ah, no. Ahí sí.
Now,
It-
Pat,
Ok, ahí está listo.
right. Thank you.
There you go. Right, you can see me now. Okay. I'm not sure it helps, but anyway. Okay, so in the next few slides, I was just going to talk a little bit about the City of Nottingham, the University of Nottingham, some of the teaching we do, and some of the research we do. So just a very brief overview of some of our activities and some of the opportunities. So Nottingham is a medium-sized city for the UK. It's about 180 kilometres away from London, and it's very close to being in the middle of England. So we're very close to being in the middle of the country, as you can see on the map there. The city is famous for a number of things. It is famous for the legend of Robin Hood, and you may have seen the latest film in that area, which was done by Kevin Costner. It was also very famous for having the best football team, soccer team in Europe. If you go back about 30 years, Nottingham Forest was the best team in Europe under the leadership of Brian Clough. But sadly, the team is now in our second division and is not doing so well. It's also a very lively city. There's a picture there of the old trip to Jerusalem, which is possibly one of the oldest, if not the oldest, bar in the whole of the United Kingdom. So a very historic city, a very lively city with big spaces, good services, and a few famous people in its history. I come from the teaching department of electrical and electronic engineering. We also, within the faculty, have very strong departments in mechanical engineering, aerospace, civil engineering, doing buildings, and architecture in the built environment, as well as chemical engineering and mineral engineering. So a very wide, broad faculty of engineering. And the one I'm going to talk about is the one I know, which is the Department of Electrical and Electronic Engineering. We've got an internationally leading department. It has a very friendly staff who engage with students. One of our big priorities is to be a friendly, welcoming place. We have new facilities opening in September this year. So they're investing about $1.6 million US dollars in new laboratories for student facing work. And we have a fairly new and quite innovative teaching course with a lot of project-based learning that was launched in 2016 following a major course review in 2015. We have about 50 members of academic staff, so professors or faculty. Bioengineering. The bioengineering is particularly looking at problems around the use of electronics in medical applications. So they work very closely with our hospital, looking at how to develop new things for treating patients. One of their most famous products is being able to listen to a baby's heartbeat when the baby is still inside the mother. It's a very interesting signal processing application. So lots of good research groups doing a lot of good research in a number of different areas. The electromagnetics includes communications as well as the electromagnetics associated with EMC and with lightning strike and so on. So the one I'm going to focus on is the top one, just as an example of some of the research we do and some of the applications where that can be applied. So as it says, it's the Power Electronics, Machines and Control Research Group. And the applications we find ourselves working in are around transportation electrification and energy conversion that you need for renewable energy systems, particularly when you're connecting photovoltaic, so solar energy or wind energy, to the electricity grid. And we're one of the largest power electronics and motor drives research groups in the world. We do a lot of internationally leading research, and we currently have about $40 million worth of active research grants, with about 60% of that being linked directly to our industrial partners. The motorbike you can see there is something we built as a technology demonstrator. That is a motorbike with about 200 kilowatts of power at the back wheel and is purely electric. So it's driven from batteries and an electric motor. So the whole of that bike, the power converter, the battery system, the frame design and the motor itself were all designed and built within the university. I will say that's not me riding the bike, that is a professional rider riding around a racetrack near Nottingham. So we are into demonstrating our technologies in exciting ways, as well as doing the normal things we would do for research and working with industry. So within my research group, we have about 160 researchers and professors. So there's currently about 60 postdoctoral research fellows, about 75 PhD students, and 21 professors or academics. And we work across 5 main areas. We work on electrical machines, so the design of electrical motors and generators. We work on power electronic systems for the interconnection of energy. So if you want to connect a wind farm to the electricity grid, you need some power electronics there to act as the interface. We work on motor drives and the electrical power systems they connect to. And we work on power electronic integration. So why do things fail? Why does a power supply break? How can we design those items so that they don't break? And how can we influence the lifetime of those products whilst also reducing cost? Underlying all of this is a theme on thermal management. Anything electrical gets hot, there's always losses in that system, and so that heat has to be transferred into the air, and that requires a certain amount of understanding of heat transfer and the integral design of those thermal management systems. So the research group, as I say, has about 20 professors. We've just moved to a new building where we've got over 3,000 square meters of dedicated laboratories and a power supply up to about 5 megawatts, workup voltages up to 11,000 volts, and we can test electrical machines up to about 20 megawatts. So that's just for the research and for the research group. That's not for the teaching side. So our research themes are electrical machines and motor drives, power electronic converters, the electrical power systems that they might go into, particularly in transportation, energy management systems, making power electronics and power supplies smaller and lighter and sometimes cheaper, and then looking at the added value we can put in there in terms of diagnostics, prognostics, electromagnetic compatibility, and so on. And the applications for that in transportation tend to be in aircraft, in the aerospace sector, in automotive, looking at cars, and marine, looking at electric propulsion of ships or boats. We also do a lot of work in connecting renewable energy to the grid, as well as some industrial applications. A couple of years ago, we plotted our main international collaborations around the world. And you can see that on this map. As you would expect, we have a number of collaborations with partners within Europe, Virginia Tech in the US, a couple of universities in China and Japan, and Australia. And you'll see a big concentration in Chile. The group has been working with various universities in Chile for the last 25 years or more. The first visit was actually in the late 1980s. So there's a number of people in Chile who've come to the UK to do PhDs, to do master's programs, and that work has continued over the decades. So the research group has a very, very, very strong link to Chile. We've always enjoyed that collaboration and learning from each other. In the last 30 years, there's been over 25 jointly funded research projects and a large number of papers and citations. As you can see there, a couple of years ago, we'd had over 6,000 citations of joint papers, some papers that have won prizes for being the leading paper in their journal, including one with Marco. So lots of interesting work that's been going on there. I mentioned that we'd recently built a new building, and here's a picture of the building. It's on our Jubilee campus. We've spent £18 million as part of a £35 million project to build this facility. We've got lots of lab space, lots of workshop space, and room for plenty of people within that building. So it's an exciting time to be collaborating with Nottingham. It's an exciting time to get involved with the research that we do, and so on. I mentioned the motorbike earlier. It's a demonstration of technology, but it's also a demonstration of success. We were the European Electric Motorbike Race Series champions in 2015 and 16. And anybody who knows their motorbike racing will have heard of the Isle of Man. And we finished on the podium there for the electric motorbikes in 2016, 17 and 18. Obviously last year that race wasn't run. And this motorbike is faster around a typical racetrack than a petrol equivalent bike. We've done a head-to-head with a BMW Superbike to try and demonstrate that. We don't just demonstrate technology on motorbikes. There's a lot of things with industry, but also we've recently built an aircraft. So it's a single-seater aircraft. It's designed for racing. And we've put the drivetrain, a very similar drivetrain to the one we have in the motorbike, into that aircraft to demonstrate that you can do all electric flight with a small aircraft, and you can meet the relevant standards in terms of certification and worthiness. Just to finish, I just want to say a little bit about some of the courses that are available in electrical and electronic engineering as part of the exchange program with the consortia of universities. There's a number of modules, we call them modules or courses in your in normal translation. These are currently all available online. So all the lectures and learning material is available on an online platform called Moodle, and all the assessments are either coursework or timed open book examinations that can be taken online. So we've had to put this in place because of COVID, but some elements of this will probably stay with us in the future. So all the lectures can be accessed when the students want to. They get uploaded every week, but there's no requirement. The time at which the students choose to access those lectures is up to the students. Each lecture is in a 25-minute segment so that they are of the right length of time and in the right format to be attractive when they're listened to. So we've cut that time right down, and there's quite a lot of those, and the associated learning materials with them. Writing a list of courses that are available is always difficult because the list is often changing, but the typical modules that are available in this kind of program are listed there. And these cover the full range of applications, computing, communications, electrical and electronic engineering subjects. So you'll see there things like IT and cybersecurity, the power electronics, radio frequency engineering, programming of both computers and of programmable devices like FPGAs, sensing, should be some signal processing and control in there, and so on. The contemporary engineering themes module is an interesting one in that this is looking at a number of different worked examples of the application of technology and how that impacts on our lives. So transportation electrification is just one there, but the impact of electronics in medicine is another. Communication technologies beyond 5G is another, and so on. So a lot of modules there with a lot of different topics taught in a lot of different ways. Hoping you can still hear me. I've got some computer problems.
Yes, we can still hear you.
That was actually the last slide. So my next slide just says any questions. So if anyone's got any questions, I'm more than happy to deal with those either here online or through email or through the chat function.
Okay.
So, thank you very much for listening. I'm sorry about the slight technical hitch, at least I have at the moment. But
Okay, thank you, Pat, for your presentation. We have two questions. One for Leo Gonzalez. How many years do you have to study at Nottingham to get your degree? This is the first question.
Okay, the answer to that is it depends. Our basic degree courses from year one, which is typically people who are 18 or 19 years old to the end, is 3 or 4 years. We do have a foundation year before that, which some people take if they don't have the right backgrounds. And yeah, but our basic degree programs are 3 or 4 years long. The master's course is either 1 year or 2 years. That is slightly misleading because it's actually, we split our academic year into 2 semesters, but the 1 year course teaches throughout the summer as well. So we actually end up with 3 teaching semesters. So it's, if you do it in 1 year, it is very, very hard, intensive work for a full 12 months with no real holidays in that time. So quite a few students prefer to take it as a 2-year course. Our PhD is a 4-year course at the moment, typically.
Okay, thank you. Federico Corral wants to know, does exist any restriction about age when a person wants to apply for a PhD program?
My oldest PhD student started when he was 60 years old. So no, there is no restriction on age for PhD.
Okay. Daniela Constanza, how can we know the available courses of other engineering?
I can make a list available to you for that. Yeah, that's probably the easiest thing. If I send a list through to you to distribute on that. The other answer is to go onto the website, and there are links to that, but it's a little bit hard to find if you don't know where it is. So it's probably easier for me to send you a list.
Okay. Aníbal, how many courses can one take in a semester, and how long does a class last?
Right, okay, so all the courses fit into one semester. How many hours of study that course is varies a little bit. Some of them are twice as long as others. So what I'll do after this is to send through some links which will link you to some information about each of those courses, so that you know exactly how long each course will be and how many hours of study. And then there's some equivalents to the type of credits that you use in Chile from the type of credits we use in the UK. So typically each course in the UK terms is either 10 credits or 20 credits, and a complete academic year requires 120 credits. So somewhere between 6 and 12 courses. I don't know if that made sense, but I can send that information through so that that can be read.
Okay, thank you. Leo Gonzalez asks, which areas of electrical engineering do you think are the most important for the coming years?
I might be slightly biased here, but the two big areas in electrical engineering where we're seeing most demand for graduates to go into employment, into jobs, are in the electrification of transportation. So how we make cars all electric, how we make aeroplanes more electric, and so on. We're seeing a lot of work around automation. So how to make things less reliant on human beings for control. So self-driving, for example, is a good example of that. So that cuts across electrical engineering, but also communications engineering and control. And we're seeing a lot of demand and a lot of work in connecting renewable energy to the grid. And one of the leading countries there is, of course, Chile, with the PV solar energy in the north, not particularly in the north. So if you're going to connect a lot of renewable energy sources to the electricity network, that requires a lot of electrical engineering. And that is going to be a big area of demand, not just in the next couple of years, but for the next couple of decades, as the world moves from a culture of oil and coal to a culture of renewable energy sources to feed our electricity networks. So I would say those are the biggest areas, and that's certainly reflected on in the employment statistics we have for students.
Okay. Jose Manuel asks, how likely is that taking a course will open up opportunities for face-to-face exchange in the future?
Well, all our online courses, oh, hang on, let's think how to word. All our online courses do have interaction with the lecturers that can be in real time. At the moment, most of that is obviously through Teams or Zoom, because it has to be distanced. I would hope that once we're through the current pandemic, that that these courses will be available face to face for students who wish to come to the UK on exchange. That was certainly the original plan, and I don't see any problem with that. So I see the only problem there being the pandemic.
Okay. Next question is, where can we find syllabus or more information about the exchange courses?
Right, so I'll send some links which will take you to some information on each of these courses. And if there's if we can deal with that after this meeting, that's something that I'd be happy for it to be circulated. So it's all online, but I'll send you some links on where to find it.
The next is about electrical transportation. How many cycles of charge can a battery have? And is there anything to do with the batteries when they fail?
Oh, that's a very good question. Like anything, batteries do wear out. They do have failure mechanisms and they do have wear out mechanisms. So every time you charge a battery, every time you discharge a battery, and every time you get it hot or cold, its lifetime, you eat some of its lifetime. You use up some of that lifetime that's available. The problem is there isn't just a number of cycles. It depends how you use your battery. To give you an example of something we all use, we all have a mobile phone. If you put this mobile phone on the dashboard of your car in the sunshine every time you go on a journey, the battery will have a shorter lifetime than if you treat it very nicely and always keep it in an air-conditioned room, because the battery doesn't like getting hot. It doesn't like that extreme temperature environment of being in the sun behind glass. So it's exactly the same with a battery in a transportation system. So we're expecting to see batteries in an average car or truck or bus lasting somewhere between 8 and 10 years. Now, by lasting, we're expecting to see them going down to 80% of their original energy storage capability. That will be extended considerably if you look after that battery. So if you don't get it too hot, if you don't get it too cold, and so on. So depending on the climate you live in, and depending on how much the car does to help you with that, does it in terms of cooling and so on, will depend how long your battery will last. Now, obviously, when they're finished using them in the car and the capacity isn't so high, then the next thing you need to look at is a second life for that battery. And typically you can find plenty of applications for that. For example, if you have a photovoltaic, a PV, solar energy place, it is very useful to be able to store that electrical energy so that you can still create generation onto the network at night. And that's one of the areas where we expect to see second life batteries used. And there's certainly a lot of work ongoing in how to determine the state of health of the batteries, as well as how to package them and use them safely in that second life application. So, and in that second life application, you could expect another 10 or 20 years of lifetime before you then have to recycle those batteries. So that was a very long answer to a very good but very interesting question. Sorry.
Okay, 2 more questions. Is there a course that talks about green hydrogen?
Hydrogen there's one of the courses that I think was on the slide, which was around sustainable systems, and that does include hydrogen as an energy vector. So and it does compare that with other sources of energy and how they may be used. So it's included in the sustainability module rather than being an independent module on its own.
Okay, and finally, how chemical engineering is related to this program?
Right, okay, so I'd have to refer to other people who run the program from the Chilean side, but in Nottingham, the Faculty of Engineering has 5 different departments, and a range of those modules can be available for exchange. So chemical engineering is an interesting area because it includes the electrochemical type technologies such as batteries, but also includes things like mining as well. So and environmental impact and things like that. The sustainability in terms of buildings and way of life is actually in our Department of the Built Environment. So that sits separately to that. But that's just the structure of which we use in the UK.
Okay, thank you. Now Marco has some questions. Marco, please.
Thank you very much, Victoria. Pat, I have some general questions, especially for those students that will be interested in to apply. So if they apply now or in the next couple of weeks, when it's supposed that they will start the course?
So, one of the challenges for the exchange scheme is that our academic years do not align because of the difference between the northern and the southern hemisphere. So our 2 teaching semesters, one runs from the middle of September to the end of January, and one runs from the beginning of February, which I know is the summer holiday in Chile, through to June. So those are our 2 teaching semesters that we have. So typically they start with 12 weeks of teaching, 1 or 2 weeks of reading and revision, and then a week for the examinations.
Super. I will say that in Spanish just to clarify to some students.
Yeah, please do.
Si ustedes, los estudiantes, postulan ahora para este programa, en general partirían en agosto, septiembre con los cursos, por el hecho de que hay un desfase entre los semestres, tanto en Inglaterra como en Chile, por el cambio de hemisferio. Y es por eso que si hay algún estudiante que postuló el año pasado y no comenzó en febrero, debería comenzar ahora en agosto. Así que es importante que lo tengan en consideración. Y otra cosa más que quiero destacar es que en el caso de la Universidad de Talca, no estoy al tanto de cómo es la situación con la UFRO y la UBB, pero en el caso de la Universidad de Talca, los estudiantes que postulen y que hagan los cursos, los pueden convalidar en sus carreras, ¿ya? Y esto se canaliza a través de la Dirección de Asuntos Internacionales, quienes reciben la calificación que enviaría en este caso Pat, como el encargado en Nottingham, y el director de Asuntos Internacionales hace llegar sus calificaciones a los directores de escuela, tanto de Eléctrica como de Mecatrónica, para su posterior convalidación. Por lo tanto, los cursos que ustedes pueden tomar, al menos en el caso de la Universidad de Talca, se pueden convalidar y pueden sumar créditos a su malla en su carrera. Okay. Pat, I have one more question regarding the double degree program, because there are some students interested to apply for a PhD program. And as well, they can apply for the PhD program in Nottingham. They can also apply for a PhD program in Chile and to apply for the double degree with Nottingham. Can you talk about that a bit?
Yeah, maybe in the future we should do another one of these just totally dedicated to that program. But there's an opportunity to do a PhD where you spend half the time at the university in Chile and half the time in the UK in Nottingham. And for a student from Chile, you would start off your PhD at the Chilean university, applying for that in the usual and that PhD position and maybe the funding in the normal way. And then there's normally an opportunity to apply for international travel. And at the time of the qualification exam, if you also apply for a PhD in Nottingham on the dual award programme, then that enables you to come to Nottingham for part of the study. And it enables you to have supervisors both in Nottingham and at the university in Chile. And then interestingly, you don't finish with one PhD, you actually do one examination, but both universities will issue you with a PhD certificate, assuming you're successful. So you end up with two PhDs, one from the UK University, Nottingham, and one from the university in Chile, such as the Universidad de Nottingham. So that scheme is it's a very nice scheme if you want to have the experience of working in a different country, a different view on research, and use of different facilities with different capabilities. So it's a very good scheme to get that experience, to have different supervisors with different opinions and different knowledge, and a really good experience. And to give you some idea, the first Chilean student who did a PhD in my research area under this scheme actually won the prize for the best PhD of any Chilean student that year. So the quality of PhDs is seen as very, very good. I'm not sure if I've missed anything there, Marco. I hope I've got most of that.
Yeah, thank you. Perfect. And finally, one more question regarding the number of vacancies. How many students can apply for this exchange program?
I don't know the answer to that. Is there a limit on your side, from the Chilean side?
No, at least in my side, in our side, there is no any limit, but probably in yours. This is why I asked it.
It's the reason I was trying to not answer that question is it's something we need to discuss. Certainly, the numbers we're looking at the moment are not a problem. Some of the courses have limits on the number of people attending the course, and actually that's what will generate the limitation. So at the moment, there's no quota or limit to what we can do in terms of numbers.
Super. Yeah. I think that there are all the questions. There is one question from Aníbal Villagran, but I will reply in the chat. Thank you, Victoria.
Okay. Thank you, Pat, for all the information and for this meeting. Bueno, ahora recordarles a todos los estudiantes que pueden acercarse a los encargados de cada universidad. En el caso de la Universidad de Talca, con Marco, en el caso de la Universidad del Biobío, con Natalie Rizzo, y en el caso de la Universidad de la Frontera, puede ser conmigo o bien con Susana Candia. Así como dijo Marco, cada universidad ve los asuntos de convalidación de estos cursos, así que, bueno, para más información y más especificidad, como más en detalle, nos pueden escribir un correo. Vamos a dejar los correos en el chat. Y no sé si alguien quiere decir algo más del equipo. Don Cristian, Marco. Chao nomás.
Thank you very much, Pat. It's really a very good opportunity for our students.
Thank you very much.
No, well, thank you very much for the invitation. It's always very nice to talk about Nottingham and the collaboration with Chile and these opportunities are something that's very important and great fun for all involved. So, and as I say, I will send some more information through And if there are questions, please let me know, and we'll do our best to answer those. But thank you very much for the opportunity.
Thank you. Yo quiero terminar también dando las gracias a las personas que participaron de esta charla, a los organizadores, y motivarles a que postulen, a que aprovechen esta oportunidad. Es una oportunidad que no siempre está disponible para nosotros, y es una buena instancia no solamente para poder practicar nuestro inglés, sino que también para poder ver desde otra dimensión y adquirir nuevos conocimientos para nuestra carrera. Así que les motivo a que postulen y que puedan participar. Eso, muchas gracias, que estén muy bien.
Gracias a todos, que estén muy bien. Nos estamos comunicando.
Chao, chao, chao.